Xin chào quý vị đến với Hoàng Uyên Technical Corner. Tôi là Hưng, giám đốc điều hành của công ty trách nhiệm hữu hạn thương mại giải pháp công nghệ Hoàng Uyên. Chúng tôi thường làm những chương trình nhằm nâng cao kiến thức về gia công cơ khí chính xác. Thì chúng tôi thường mang đến quý vị những chương trình bổ ích về chiều sâu, về công nghệ và kỹ thuật, nhằm giúp quý vị nâng cao cái khả năng gia công cơ khí chính xác, tạo nên sản phẩm có chất lượng cao. Thì hôm nay chúng tôi mang tới với quý vị một chương trình nói về kỹ thuật lăn nhám, và chúng tôi mời tới trường quay một vị khách mời mà ông chính là người đại diện cho một hãng rất nổi tiếng của Thụy Sĩ chuyên về lăn nhám, và họ đã hoạt động rất lâu trong ngành về lăn nhám. Và hôm nay chúng tôi mời tới đây ông Olivier, và mời ông cùng tham gia chương trình với chúng ta. Welcome Mr. Olivier joining to ride with us. I know you have just landed down Ho Chi Minh City from Switzerland and you are tired, so I took you here joining with us for the talk show. And thank you so much. I hope your pleasure and you can join when we record the program and publish on the website and on YouTube on the fan page. I hope your knowledge and your experience and your techniques you tell today to help the visitor, to sell people can understand well Knurling.
You bring me a huge motivation. You know, every time I'm coming here, it's so nice. So we'll do it. Thank you.
Thank you. So, Knurling, what is Knurling? Wow.
Knurling, wow. Knurling is cold forming, actually. Knurling is a very old process, probably used since many decades, and this is actually deformation of material. So this is cold forming, we could say, in a technical point of view. Process is very quick, very efficient, but is non-digital, is not really accurate in terms of precision. There are some things you cannot do with knurling. For example, gear, or it's not very precise. You cannot make an assembly with it. But knurling is very useful for a lot of things. For example, when you need, I have part I can show you. When you have part that needs to be overmolded or pressed in, you see this one, for example, is a classical one. This will be pressed by force in another part. And knurling is a perfect process to ensure this profile. And this is the other classical use. This is a grip, a part that need grip for instrumentation. This is also very big classical use of knurling.
It's like reinforced applications.
No, not really. This is because you deform the material, but you make a pattern on the surface.
Yes.
And the use of the pattern can be multiple. Jewelry, watch industry, crown for watches. But the big volume is this: grip or press part or overmolding part. Yes.
I see. And when you say it for knurling, but now I wish to know purpose of knurling, the application, some, and in detail.
The purpose of the knurling is to bring a pattern on a part in a quick and dirty way. So it's cheap, it's quick, it's very efficient, but it's restricted in terms of precision or in terms of accuracy to another part, for example. So there's usage that cannot be covered with this process.
Nice.
But if you need just grips or some patterns on the surface for standard purpose, we have, for example, handle in shower. Handle in shower are frequently knurled with a pattern to ensure better grip, also with wet hands. This is a classical use. Yes.
For machining, mechanic machining, we can remove material like drill, like turning, like milling, like cutting, or we deform material by punching or press. With knurling tool, with how to make the forming material by cutting or by form?
Both. The main use is made by deformation. You press in. We bring material and print a pattern in it with the wheel. The material is flowing and filling the profile.
Yes.
Building up this toothing. If you have cutting, knurling by cutting, it's actually knurling by slicing. We have in the small video that we show you just afterwards, we see that the classical knurl is made by passive rotation. Yeah. The tool is coming on the part, take over the speed and run. And here we have exactly the same speed between at the contact point between roll and between part.
Material and wheel.
Yes.
We have two wheels.
Yes.
Yeah.
Slicing or cutting, the wheel is slightly with an angle, and this gives you a differential in speed at the contact point. The wheels are made sharp so that you have a cutting effect.
Yes.
And you take out material, small chips.
It means different speed between material and
the
wheel.
rotation part.
Wheel.
Yeah.
Because it have a little bit angle.
Yeah.
It's like milling.
Yes. It's a little like milling, but milling is active. The milling tool is driven by the machine.
By machine.
Yes.
Right.
Yes.
Yeah.
So you come out of material, you still turn and you come in. So you do not need to find out your place every time. By knurling, every time that you have a rotation, the tooth must find its way again.
I see.
And this is somehow challenging for people that are not used to this process.
I see.
And this is the reason for we made a lot of small videos and pictures to help understanding the process.
2 weeks ago, I met one customer. The only thing knurling is forming. He don't think it's a material sliding, cutting, as you should say. Yes.
When you slice the profile.
Yeah.
So the tooth of the tooling will really make the same profile in the part. When you deform, you press material down and up.
Yes.
And then you have two flow of material coming together. And this is the reason for some material as, for example, brass or gray iron, you cannot make a knurling by deformation because gray iron has no elongation.
Yes.
Then you need to use knurling by cutting or by sliding.
When we see one workpiece, how to recognize, define this is a cutting way or a deformed way.
It may be difficult by small parts. By bigger part, you can see it on the. You see traces, you see lines on the part. Usually, knurling by slicing or knurling by cutting give you a better surface quality. Yes, because you do not have to let move the material.
Yes.
And if you have some stainless steel, then it's better to use deformation because it flows and it's not so easy to cut.
But forming tool, we make material deform, right? Forming tool deform. For some material have very thin wall and very small deforming effect and disadvantage, right?
You cannot. You have to follow some physical rules. So if you have a thin wall tube and the wall thickness is lower than the pitch of the knurling tool, then you will not be able to knurl by deformation.
Yes.
Something that is used frequently, the handle that I show you at the beginning, this is a typical use of this. You scratch the surface to make the grip. This is a low-cost process. It's not really a nice knurling, but it's very effective. And this is frequently used for that. And it's the only way to knurl a tube. Because if you really want to make knurling by deformation on the tube, then you will destroy it. It will bend. Yeah.
But what machine we use for knurling tool? By hand, okay, or by just a CNC machine, autolathe, for example, can be.
What we have is Swiss typlars for small part, the one that I showed you, for example, or classical turret CNC machine for bigger parts.
But how to confirm which one enough for the pattern finish?
There is different patterns. The classical one, you have either a straight one. This is, I'll show you it's better with my gloves. You have the straight one. This one, straight. RAA, classical one, or type A. This is standardized. And then you have another one, the crossed one.
Nice.
And the crossed one by 30 degree, so known diamond knurl, is also standardized. And this is the type B. But you also have 45 degree, you have knurl impressed, and not only raised. So you have a lot of different way of knurling, but the pattern is either a straight one or a crossed one, usually.
This is two types for pattern.
Yes.
One crossing and one for thread.
Yes. Yes.
When we use thread, what we use for thread?
You mean the crossed one?
Yeah.
Okay. The crossed one is used usually for grip when you need.
I see.
To have instruments, for example, dentist instrumentation, they need grip because they have gloves. This classical way. So everything that is done with grip is a crossed one.
I see.
And then you have overmolding. It depends a little on what you do and in what for material. But this is also frequently a crossed one. Or maybe a combine with a left-handed and right-handed knurl, and maybe a groove in the middle.
Yes.
We have a picture. We will show it to you now.
Now we say more detail. How to knurling come to material when material rotating, and the wheel come material, touch material, and running and finishing by method pattern. Step by step. I mean, for people can understand well.
Yes.
How it works.
We have a small video that we can show, but the principle is so. You have your part is rotating. The tool is passive. You bring it and press it to the part.
For radian,
on the axis. And then it starts. And then you have
material.
Yes, it touch material, and then you have to press it in the part swiftly, because as soon as the rotation is done, the tooth of the tool must find its way again.
I see.
To avoid overrun and really a problem.
It means the tool, at that time, the tool and material was same speed.
Yes.
Same speed.
Yes.
No slip.
No.
Same speed.
Yeah.
But when it's touching, we must overforce, right? Little bit overforce for deformed material.
And this might be an issue for small part. If I take again the small part that I have here, this one, if you go only by side, you will press it out.
Bend.
So you have a problem on the quality of the knurl, and you also have a problem with the fixture of the machine, with the bushes and the guide bush, because you will damage your machine with the time. So for that, we have a special solution with a holder with two wheels, where the forces are brought directly in axis.
It means center line between the wheel and the center line of material same line.
Yes.
It was a force direction on the radial force to apply to material.
Yes.
Nice.
Yes. To compensate the radial forces.
Yeah. Radial. Now, when knurling wheel touch material, have two things, right? One is touch material offset the center. One is center line of center. How to work? Which one is a application suitable for?
It depends on the machine that you have, the quantity, the volume of production that you have, and the equipment that you are used to take for your knurling operation. There's a lot of different way and different holders, but there's two families actually. One is single wheel directly on the axis.
Yes.
For cutting as well as for deformation. Then you have double. Double is used for crossed knurl. That's need a longer area, a longer pattern that are wider than the wheel itself. Knurling is a closed shape, so you cannot have a crossed wheel because this exists, we produce it, but you cannot run. You cannot cannot feed sidewise with this. You have to make it that way only. And this is very limiting. So this the reason for we use two wheels, because then you can come in and run. Then you have your pattern made all along the part.
But when it have a double wheel come in, the center line of wheel and material is same line, right?
Yeah.
It means we must adjust the gap between the wheel and the diameter of the material.
So there's by Ifanger, we have three different holders for that.
I see.
We have one that is for general purpose, a bigger diameter.
I see.
Where you have to position the middle of the holder to the axis of the machine. And then you will have your wheels not over this patch, but sidewise. And then you have to press in that way. This is the first one. The second one is dedicated for a specific diameter. A classical use for watch industry is, for example, a chrome diameter 3 millimeters in some stainless steel or gold or whatsoever. And here you use a double holder with a fixed axis, with a fixed dimension. You cannot change the bar that you are machining. You need to use, if it is set for 3 millimeters, it is set for 3 millimeters. You cannot do something else on it. And here you have to also to position the holder to the middle of the tool, of the part. And then you have another one, more universal, with a range, where you can adapt the position of the both wheels with an eccentric system. And here you have to take care of the position, to have roughly the two wheels dispatch in the same way. But you still need to check MI to the axis level. This is very important. If you are not, you will have an issue with the pattern. Because one of them will be more impressed than the other one.
I see. I see. And the angle different. Maybe have it not the same line.
Can be. What can happen also is something like that. You may also have a kind of spiral due to this. Also possible.
I see. I see. And when we make back the knurling, we need the coolant and cleaning.
Yes, for two reasons. Because you need to cool down the tool. You have a very high friction between the axis and the wheel, because we do not use coolant? No. To let run. What you use normally in the car and something like that.
A bearing?
Bearing. We do not have any bearing in our system. We have a fixed axis and the wheel on it. And the friction can develop a very extreme heat, and this will block the system and destroy the system. So you need to cool down. This is the first thing. The second thing is you are printing your profile in your part, but you print everything that is coming with.
Yeah.
So if you have burrs, chips, or something like that in the wheel, it will be printed out in the
material.
part.
Yeah.
So you need to wash also.
Yeah.
So we said, hey, flush. Doesn't matter if you use oil or if you use emulsion, but you need to cool down. You need to flush. You need really a lot of coolant, and this is then a good thing.
About the brush material, copper, easy to touch inside the roof of the wheel, right?
This is not a big issue in it. What is special with the copper or aluminum or some specific alloys is the friction on the surface. And if this friction is too high because material tends to to glue, and then you need a surface treatment, you need a coating to reduce the friction, to avoid the limitation, to avoid breaking the material flow. Because if the surface friction is too high, the material will not flow properly.
Overforce.
Yes. And then here we have different standards. WCC for non-iron alloys. Stainless steel is perfect with this. And we have DVA. This is a very specific high-hand coating. Looks with a bronze color. This is this one.
Different coating.
This is a completely different coating.
Different coating for different material.
And this one can be used also for steel, carbon steel, for a lot of things. This is actually good for everything, but it's costly. So if not necessary, then WCC is perfect.
I see.
Yes, it's a graphite base, so you have to be careful with the carbon that you may have in the steel, for example, because this will recombine with the coating and destroy it. It's the reason for that we use DVA or nothing. But DVA is really good for carbon steel. Yes. But also for Nymonic, Inconel, all that stuff. And then because we are speaking about coating, for the cutting tool, we use TIN. This is not really changing the game in terms of cutting or resistance of the tool, but this is giving you a nicer, a smoother surface quality. So if you cut a knurl in stainless steel, TIN is also a good choice.
I see. Now, what on-step in sequence operator should do to complete the knurling process in detail?
In detail. First, check the drawing and have a first look and control to see if the expectation given by the drawing are okay for knurling. This is the first thing. If the guy designed everything with really tight tolerances, a certain amount of teeth and I don't know what, then be careful and discuss first to check if knurling is really adequate for that. Then check the pitch, because you need a certain amount of teeth around the part. The passive process can only run if the wheel is driven by the part properly. So it means you shall have enough teeth printed out in the part to ensure a proper rotation of the tool and proper process. And here we said roughly 16, 17 teeth is okay. If you are lower, can be risky. So this is given by the pitch in relation to the diameter. And the pitch shall not be that high that you have only 3 or 4 teeth around the part, because this is something you would have to produce in another way, not by knurling. It's not accurate for knurling. This is the second step. Then you have to choose the technology that you want to use. Is a single wheel possible and okay or not? Due to size of the machine, size of the bar, pattern that you need to press in. This is given frequently by a catalog of the suppliers. Ifanger has a very wide choice, so we can do a lot of things with a single roll, because this is the easiest to set up, but you need the conditions to be fulfilled. This is then the third. Fourth, then you have to check the position of your tool in Y. So you need really to be at the axis of the part to have a proper and nice knurl made, a nice profile made on the part.
Center line, same center line of material, right?
Yeah. This is important.
Yes.
Then about speed, we have recommendation in our catalog. We have a spreadsheet for that. The speed is low. It's something between 20 and 40 meters maybe. In aluminium you can go higher, but not more than that. So VC is low compared to machining with CBN insert or such kind of things. So this is something that people need to know. And then the feed rate. When you plunge in, then you need to be swift and go in really quick.
I see.
And to be sure that the wheel will run properly. And this is possible only.
How many revolution at the first time to make sure it's enough to make pattern?
2 revolutions.
2 revolutions enough, right?
Yeah, this is theory. We say half of the pitch by revolution, and then wait 1-2 seconds to let the material take its position, and then you can either it's finished, you come out, or you feed sideways.
With some material, when we touch and just do revolution, when moving away, it return again. You have ever some plastical deformation, but it's small. It's very small. So a proper knurl is only deformation, or practically only deformation, and you do not have a real change that you would notice after the wheel is off. Yeah, the change is not really noticeable. It's so small, it's not noticeable. But what is important to know, you plunge in half of the pitch by revolution, you wait 1 second, 2 seconds, and then you can feed sidewise, and here much slower. So here we speak of a feeding rate of maybe 0.05, 0.08 millimeters by revolution, not more. We also have recommendation for that, depending on material and size, etc. So sidewise feeding is much slower because you must imagine the rotation of the wheel, and you move that way. And this material will be cold deformed. But as the wheel is moving, you take a little more every time. And if you go too swiftly, then you will destroy the tool because it's too much then. I see. It's
and
two
then
direction force. One axial and one radial.
And what you may also have is an issue with the guide bush and the system of the Swiss type last, because you could push the bar. You could push the bar back in the machine. This should be avoided. This is not a good thing.
The collet judge must be strong enough for clamping.
And cool down. So cool down. You do not need a very high pressure for that, but you need a lot of liquid.
With it for.
And when you come to the end, let's say you feed sidewise. When you come to the end, First, you go out
and
before stopping
I see.
the feeding
I see.
to avoid a change in the surface look of the part. Because as soon as you stop and run, you will have another surface quality.
What's
The brilliance will be different. If you have stainless steel, for example, then it will be much brighter the last millimeters than before. So to avoid this, you shall run take out. So run that way and not so.
It means we made for light chamfer, little bit chamfer at the end.
We have a chamfer on the wheel.
Why? Because I understand why we must move out of material first
to avoid stop. Because if you stop the feeding and wait, material
keep on running,
and the system will press a little more the surface of the material locally, and this will give you another brightness.
I see.
Locally. Most of the case, nobody cares. But if you have a customer, customer that is requiring a constant and perfect color, this may be an issue.
I see.
This is also an issue with knurling by cutting, but at the beginning. Knurling by cutting, you first need to plunge to let the system run.
I see.
And this is deformation pure. And then you feed sidewise. And this causes the diameter at the very beginning, the 1 millimeter that you plunge in on the side, on the width of the wheel, will be bigger than the cutted that is coming afterwards. So you plunge, you run, take out, and you finish the chamfer by a turning operation at the end.
I see.
And then the process shall be completed.
When we say this, any relationship between feed, speed, pitch, and diameter of material?
Yes.
Any calculator?
Yes.
Formula, something?
There is formulas, but they are quite complex. So we have spreadsheet giving a range and indication, and this is in most of the case it's good enough.
It's based on material, diameter, pitch, speed, and
and also the type of knurl. A straight knurl performed or behave differently than a crossed one.
So we have inside the catalog, right?
Yes, this is the catalog.
How to use. How to calculate the condition.
We have a spreadsheet given the recommendation, a simple one, by knurling, by deformation, diameter, material so and so, pitch so and so, and then you have your indication for the speed and for the sidewise feeding.
But any maintenance when the operator setting up the tool on the machine and repair the bore diameter, or some make a grooving or solder or something.
What will happen with the time? Of course, the wheel is suffering because the wheel it's high-speed steel, tempered, so hardened. This one will suffer with the time. But in most of the case, you just have to turn it, and then you can use the other side. Because this is the area that is suffering mostly. So you can turn it and go again. You can use it a little longer.
But why we just use high-speed steel, no carbide material?
We use it also. We also have. There's two things. Carbide wheels are expensive and fragile. They are really shock sensitive. Carbide wheels are absolutely good and perfect in brass, for example. Mass production of brass knurl is really good. And for some other few alloys. But we say first start with an HSS wheel. Look, is there any coating that may be necessary? And afterwards, check if you want to go to carbide or whatsoever, because the carbide is really expensive. Yeah, because we need to grind profile.
Yeah.
I have a picture. We can show how we make it, because we use hot mill. So we have parts that are cut off as raw parts, and then we mill the profile in it with hot mill. And this is very precise and very nice process, very accurate. And this is making the price difference, because you need to grind one tooth after one.
I see. You do have any demonstration for success? One success story, something for Ifanger to make very good, perfect as customer, and very good performance.
The part that I show you, this one. At the beginning, the guy was able to make 7,200 pieces.
7,200.
Yes, and then it was finished.
This is
stainless. This is stainless steel. This is no butter. This is really tough material. Then we moved to WCC, increased drastically the lifetime already, approximately to 15,000, doubled more or less.
I see.
And then we moved to DVA, and now we are by 40,000 pieces. And so this is really something well looking, really. Yeah.
Customer get profit, but you lose profit.
I sell less tools. That's right. But you know,
but the same price.
Coating is costly, but there's no relation. I mean, it's still a massive improvement for the customer.
Yeah.
And this makes sense. You know, we are a tool maker, yes. So I like to sell my tools, of course. But it's really good when you get a feedback from the customer that you improve the lifetime, that you reduce the costs, that he was able to run more and longer night shifts and so on, headless production, thanks to tools that are performing. This is really something good.
What thing made it big change? What thing made it big change? Because when you
I didn't understand.
When we use new wheel for our same application, we change to new wheel. What changed the wheel make big change as customer?
When you started with an HSS blank without any coating, you define your speed, you define your process. When you run it with coating afterwards, you can slightly increase the speed.
Yes.
You can maybe, depends a little on the profile, you can maybe increase also the feeding rate, so you can reduce the process time. But the main result is in the lifetime. Because what we try to do, this is our philosophy, the customer shall run his machine, and the machine shall not define the maintenance time and so on. So if you say, okay, I want to produce 3 shifts, I have my maintenance staff doing the job every day, I expect from my tools that there's no surprise Sunday night at 3 o'clock. And this is where we try to really to be reliable, to support our customer with a high quality tool and process to increase as far as possible the safety in production and the reliability and the ability to plan, to schedule your maintenance. Because this is really important, especially in mass production.
That's very impressive result, I think. Finally, we say about customer care and after-sales support. What Ifanger can do it?
So this is what we do and what we did also in the past. Online, but also locally. I'm coming here for the second time for this, to train your people so that they are confident in the product, in the expectation that the customer can have around the process. And this is for us very important, to work with partners as you that are able to discuss at the machine by the customer and make the support, or at least if there's really something special, to gather the information back to us so that we can support out of Switzerland. Because you are my speaker here. I do not speak Vietnamese. So the guy that is stuck at the machine needs somebody that is able to understand his pain, take it over, translate it, maybe solve immediately, or bring it back to us so that we can really bring something. So this is the way we are working. Yeah.
We have some program online program. We show video clip and some training and some technical seminar like this. We say technical perspective, technology, something like this. So I make Ifanger have some support on material and from some success story, something. So we can publish on the web and the customer can understand and learn how it works. Sometimes customer running, normally he run and he has experience already, but sometimes he had something he didn't understand well.
Or you have something special, you have conical knurl, you have a lot of things we didn't speak about, but that are related to knurling. And here we can really support from abroad by getting the drawing and making recommendation. Is something we do really with pleasure. You are in charge of your customer, the logistic is yours, the commercial is yours, but we support. And what we do is not only success stories, this is marketing, but on a technical point of view, support point of view, we prepare a lot of materials that can be easily translated so that you can bring it in your language and with your words and with the way that your people can really communicate it properly. This is what the support we do.
We have a lot of material, library or something like that, right? Chúng ta vừa trải qua một cuộc nói chuyện thú vị với ngài Olivier tới từ hãng Ifanger, là một hãng nổi tiếng về microboring và Knurling, có nghĩa là lăng nhám. Thì qua cuộc nói chuyện này, chúng tôi hy vọng rằng quý vị có những thông tin bổ ích để phục vụ trong công việc gia công sản phẩm của mình và để tạo ra những sản phẩm có chất lượng cao và hiểu cách làm sao để có những sản phẩm theo ý. Cảm ơn ngài Olivier đã tham gia buổi talk show hôm nay và hy vọng rằng là chúng tôi sẽ gặp ngài trong những lần tới. Thank you a lot for joining with us. Thank you.
It's a pleasure.
Yeah, thank you. Cảm ơn quý vị. Thank you.